Bismillahirrahmanirrahim. New syllabus Physics SSC 1 Unit number 2 Kinematics Exercise 2 Numerical Problems 2.1 to 2.5. In this chapter, total numerical 2.1 to 2.10, 10 numerical. In this video, we solve first 5 numerical 2.1 to 2.5. In first numerical, a train moves with a uniform velocity of 36 km per hour for 10 seconds. Find the distance traveled by it. Given data, v is equal to velocity is equal to 36 km per hour. 1 kilo is equal to 1000 and 1 hour is equal to 3600 seconds. So we have 36 multiplied by 1000 divided by 3600 meter per second. The final answer velocity v is equal to 10 meter per second. Given time t is equal to 10 seconds. So we find the distance s. Formula s is equal to Vt. Solution, putting the value s is equal to Vt, then s is equal to 10 multiplied by 10. 10 multiplied by 10, then distance s is equal to 100 meters. Result, the required distance of train is 100 meters. In question number 2, a train starts from a rest. It moves through a 1 kilometer in 100 seconds with uniform acceleration. What will be its speed at the end of 100 seconds? So, given data, a train starts from a rest, so initial velocity Vi is equal to 0. Distance travelled through a 1 kilometer, so S is equal to 1 kilometer. 1 kilo is equal to 1000, so distance S is equal to 1000 meter. Time T is equal to 100 seconds. Then we find the acceleration A and final velocity Vf. Then using the formula of first equation of motion, Vf is equal to Vi plus At, and second equation of motion, S is equal to Vit plus 1 upon 2 At square. Then solution, putting the values, S is equal to Vit plus 1 upon 2 At square. S is equal to 1000 is equal to 0 multiplied by time t 100 plus 1 upon 2 A multiplied by t square. 100 square is equal to 10,000. Now solving this equation, acceleration A is equal to 0.2 meter per second square. Now as we know that Vf is equal to Vi plus At, putting value in this formula, then Vf is equal to Vi 0 plus acceleration A is equal to 0.2 multiplied by 100. 0.2 multiplied by 100 is equal to 20 meter per second. So the final velocity Vf is equal to 20 meter per second. Now the resultant, the required speed of train at the end is 20 meter per second. Question number 3. A car has velocity 10 meter per second. It accelerated at 0.2 meter per second square for half minute. So time is half minute. Find the distance traveled this time and final velocity of a car. Now we write the given data. Vi is equal to 10 meter per second because its velocity is 10 meter per second. Its acceleration is 0.2 meter per second square. So A is equal to 0.2 meter per second square. Time is half minute. So T is equal to 0.5 minute is equal to 0.5 multiplied by 60. So T is equal to 30 seconds. Now we find the distance and final velocity. So we use the formula, first equation of motion Vf is equal to Vi plus At, and second equation of motion S is equal to Vit plus 1 upon 2 At square. Solution, putting the values Vf is equal to Vi plus At, then Vf is equal to Vi10 plus A 0.2 multiplied by 30. Here not a plus, we can use multiply. So the final answer Vf is equal to 10 plus 6. Now 10 plus 6 is equal to 16. The final velocity is Vf is equal to 16 meter per second. As we know that S is equal to Vit plus 1 upon 2 At square, then S is equal to 10 multiplied by 30 plus 1 upon 2 value of A 0.2 and time T 30 second whole square. Now solve this equation. S is equal to 10 multiplied by 30 is equal to 300 plus 0.2 divided by 2 is equal to 0.1. 30 square is 900. 900 multiplied by 0.1 is 90. So S is equal to 300 plus 90. So distance S is equal to 390 meter. Result, the required distance by the car is 390 meter and the required velocity of a car is 16 meter per second. Question number 4. A tennis ball is hit vertically upward with the velocity of 30 meter per second. It takes 3 seconds to reach the maximum height. Calculate the maximum height reach the ball, how it would take return to the ground. First of all, we write the given data. Initial velocity Vi is equal to 30 meter per second. The value of gravitational acceleration G is equal to minus 10 meter per second square for upward motion. So we use the negative sign. So G is equal to minus 10 meter per second square. Time taken to reach the maximum height T is equal to 3 seconds. And final velocity Vf is equal to 0. Now to find maximum height S is equal to question mark. And total time taken to return the ground T is equal to question mark. Formula first by second equation of motion. Now second equation of motion S is equal to Vit plus 1 upon 2 At square. Here S is equal to H and A is equal to G. Then this equation change in the form of H is equal to Vit plus 1 upon 2 Gt square. Putting values in solution, H is equal to Vit plus 1 upon 2 Gt square. Then Vi 30, T 3 plus 1 upon 2, G value is minus 10 and time 3 seconds square. Now multiplying the value 30 multiplied by 3, 90 plus 10 divided by 2, 5 and 3 square 9 plus minus minus. So final answer 90 minus 5 multiplied by 9. 5 multiplied by 9 45. So 90 minus 45 is equal to 45 meter. So height is 45 meter. Now we can calculate the total time. Secondly, since the ball takes the 3 seconds to reach the maximum height, it will take to the same time to touch the ground take a maximum height. So total time taken t is equal to time taken at a maximum height plus time taken to return the ground. T is equal to 3 seconds plus 3 seconds is equal to 6 seconds. Now the final result, the required height reached by a ball is 45 meters and time taken by the ball to return the ground is 6 seconds. Up, question number 5. A car moves with a uniform velocity of 40 meters per second for 5 seconds. It comes to rest in next 10 seconds with a uniform deceleration. Find deceleration and total distance traveled by a car. Given data, initially Vi is equal to 40 meters per second and time t is equal to 10 seconds. Now, the final velocity Vf is equal to 0 meters per second. To find deceleration is equal to A is equal to question mark and total distance S is equal to question mark. Solution, first by the using the first equation of motion Vf is equal to Vi plus At. Then Vf is 0 and Vi is 40 plus A acceleration to find and time is 10 seconds. Now 10 multiplied by 8, 10A and 40 move other word minus 40. Minus 40 is equal to 10A. Then we write minus 40 is equal to 10A. Then A is equal to minus 40 divided by 10. So the deceleration is minus 4 meters per second. Now we can find secondly the total distance. Then we use the two types of motion. First of all, we solve case 1 when the car moves uniform velocity v is equal to 40 meters per second. Time t is equal to 5 seconds. Distance s1. Now distance s1 is equal to vt. S is equal to vt and s1 is equal to vt is equal to 40 multiplied by 5. Then distance s1 is equal to 200 meters. Now in case 2, when a car moves deceleration with the velocity of vi 40 meters per second, time t is equal to 10 seconds and deceleration a is equal to 4 meters per second square. Now S2, then we use the second equation of motion. S2 is equal to VIT plus 1 upon 2 AT square. Now putting the value VI 40 and time t 10 plus 1 upon 2 acceleration value minus 4 and time 10 square. Then we solve this equation. S2 is equal to 40 multiplied by 10, 400 and similarly 4 divided by 2, 2 and 10 square 100. Now 100 multiplied by 2, 200. Then we write S2 is equal to 400 minus 200. S2 is equal to 200 meters. Total distance S is equal to S1 plus S2, that 200 plus 200 is equal to 400 meters. Final result, the required total distance traveled by a car is 400 meters. Thank you. Remaining numerical in next video. Best of luck.